So, I was given the standard assignment in class to find the height of an object by measuring the length of my shadow and the length of an object's shadow using right triangles. I could have done something like measure the size of a flagpole, or maybe the height of my house, but I decided to do something way cooler, find the height of a hill on the moon using just my own measurements. A while ago, I took a picture of a part of the moon using my telescope. I saw shadows inside the crater and wondered how high those craters were, so I decided to figure it out. What you're looking at right now is my paper I used to find the size of the crater and write all the math on. In the center, you can see I drew a diagram of the moon with the crater from my picture I was talking about from earlier. I made the circle that was the moon by tracing the arc of the moon in the picture and then drawing the crater on the paper to scale. I then looked up the circumference of the moon and divided by 2 because we only see half of the moon at one time. After that, I drew a line in the middle of the circle and labeled that as 3,393 kilometers, or half the moon's circumference. Then I measured the diameter of the circle, which I had created with a ruler, and found it to be 13.5 centimeters. I divided that and found that 1 millimeter on my paper equaled 25.1 kilometers in real life. So I measured one of the shadows with my ruler, and what do you know? It was roughly 1 millimeter. So I knew my height, which was 168 centimeters, and I knew the length of the moon hill's shadow, 25.1 kilometers. So now I had to find the length of my shadow, and that was it. Wait though, the time on this crater wouldn't be the same as if I had just measured right then and there. The crater's time when I took the photo was right before sunset, so I had to wait until about then on here on Earth too, so that the angle the sun rays hit me would be the same as if I were staying right there on the moon too. So the next day I waited till about 5, when the sun rays would be striking at roughly the same angle, and I measured my shadow's length, which turned out to be 751 centimeters. From here the math was easy. Put my height over that of my shadow's length, simplify the fraction, which would equal 21 over 94. Then I have that equal to the moon hill's height, or h, over the length of the moon hill's shadow, 25.1 kilometers. I would then use cross products to get 94h equals 527.1. Then divide 527.1 by 94, which would get me h equals, rounded, 5.6 kilometers. For comparison, Mount Everest, the tallest mountain on Earth, is roughly 8.8 kilometers high. So, there you have it. Using my own observations, I was able to find the height of a hill on the moon using math. Now, a disclaimer. I don't claim that my observations are entirely accurate. There are plenty of areas where you could point out things I did wrong. But the point of this was to try to see if I could ever do something like this on my own. And I could. So, thanks for watching.